Hey guys, and welcome to Chapter 2, Part 1, Topic 2, Solving Single-Step Equations by Using the Opposite Operation. So when we are solving equations, we have to remember that it's all about balance. I like to think of it as having two parts on a scale that we have to keep balanced. If we have one thing on one side, and the same thing on the other side, that is a balanced scale. If we take away one thing, it becomes unbalanced and the whole scale will tip. We have to remember that when we solve equations, whatever we do to one side, we have to do to the other. So if we look at the directions, it says solve each equation, then check your solution. So the big word or phrase actually is opposite operation. What that means is, in order to solve for the variable, we must apply the opposite operation to one of the terms in order to get that variable by itself. So if we look at number 1, we will see that we're looking at the variable d. We need to get d by itself. The only thing in the way is that -8. So we're going to use the opposite operation in order to move that -8 so that d can be by itself. So if we look, we have a subtraction sign. We have a -8. So the opposite operation would be to add 8. But if we remember the scale example that I drew very poorly, we remember that whatever we do to one side, we have to do to the other. So we're going to add 8 to the other side as well. -8 plus 8 is going to cancel out. It becomes 0. So we achieved our goal of getting d by itself on one side of the equal sign. And then all we have to do is do 17 plus 8, which will give us 25. And that is our answer. If we look at the second example, we will see that we have v plus 12 equals -5. So we want to get v alone on one side of the equal sign. If we're adding 12, the opposite operation would be subtraction. So we're going to subtract 12 from the left side, and whatever we do to one side, we have to do to the other. So we must subtract 12 on the right side to maintain that balance. Once again, that +12 and that -12 are going to cancel. And that leaves us with v by itself, and then on the other side we do -5 minus 12, which is -17. If we look at the example number 3, we have to look at what operation is happening and how do I get j by itself. 8 is being multiplied by j. So in order to undo multiplication, we have to do the opposite operation, which is division. We're going to divide by that number that's attached to the j. So whatever we do to one side, we must do to the other. So remember, when we see a coefficient or a number being multiplied by a variable, to undo that, we have to use division. Once we divide 8j divided by 8, those 8's are going to cancel out, and we get to our goal of getting j by itself. Then we do 96 divided by 8, and that will give us 12. In our fourth example, we have y divided by 9 equals -8. Since we're dividing, in order to get rid of that 9, we must use the opposite operation, which is going to be multiplication. Whatever we do to one side, we have to do to the other. So I'm showing multiplication of 9 by both sides. On the left, the 9 is going to cancel out. So we're left with just y. And then -8 times 9 is -72. And we got y alone, and that was our goal. We achieved it. Now the example number 5, I want us to be super careful, because 8 minus negative c is really 8 plus c. So we might look at that negative sign and say, hey, all I have to do is add c. But wait, minus a negative is really the same thing as adding. So in this case, we have a positive 8 that we're adding to c to get 1. So the opposite operation in this case would be to subtract 8 from both sides. Once we do that, the 8's on the left cancel, and we get c by itself on the left is equal to positive 1 minus 8, which is negative 7. Okay, I would like you guys to do the U-tries on this page. Remember the opposite operation. And we need to make sure we're really careful about questions like this one, where we are really subtracting a negative, which is the same as adding. So go ahead and try those. Pause this video. Right, and the last examples we're going to talk about is what happens when we have a fraction. So, if we look at that first example, we have 2/3 being multiplied by x. So what we need to do to get x by itself is, well, we could either divide by 2, then multiply by 3, or we can use that fancy word that we learned last unit, which is reciprocal. And what we can do is multiply by that. So multiplying a number by its reciprocal gets 1, which is our multiplicative identity that we talked about. So what we can do is multiply by that fraction that's attached to the x. But whatever we do to one side, we have to do to the other. Once we multiply a number times its reciprocal, all those terms are going to cancel and we're going to get x by itself. Now we have to do fraction multiplication. I like to put 12 over 1 to remind myself that 12 is in the numerator. If we do the cross multiplying, we can see that 12 and 2 have a like factor, which is 2. Let's divide both of those by 2. 12 divided by 2 is 6. 2 divided by 2 is 1. So that's the same as doing 6 times 3 over 1. 6 times 3 is 18, and 18 over 1 is just 18. So we multiplied by the reciprocal in order to get the answer, in order to get that fraction to almost go away. All right, if we look at the next example, it's a little bit tougher because we have the number 4 attached to the x. So what we learned before is to go ahead and divide by 4. But what happens when I divide this fraction by 4? Remember, we're actually dividing by 4 over 1, and when over here, and when we do fraction division, it's the same as multiplying by the reciprocal. So if we start over, we could say, all right, let's multiply by the reciprocal on both sides instead. So I'm going to multiply. The reciprocal of 4 is 1 over 4. And whatever I do to one side, I do to the other. And I'm going to put, oh, wrong way, 1 over 4. So once I do that, those 4's are going to cancel and I get x by itself. If I look at my fraction multiplication on the other side, I see diagonally 2 and 4 are both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So when I multiply across, I get 1 over 6. And I'm going to leave my answer in a fraction. So why don't we move on to the U-tries by using the reciprocal and multiplying by it in order to get those terms to cancel.